I'm talking about the pre-call Chapter 7, System and Matrices, and I'm the speaker, Angela. Firstly, we're talking about the definition of matrix. Let m and n be positive integers. M by n matrix is a rectangular array of m rows and n columns of real numbers. The main point is that we need to identify the order of a matrix. This is an example. The matrix has 2 rows, so m equals 2, and 3 columns, so n equals 3. So this is the 2 by 3 matrix. The second part is the matrix operation. Let's look at the definition of matrix addition and matrix subtraction. We only need to add and subtract the corresponding numbers in the respective matrix. Therefore, we can get the answer. Then, we are looking about the definition of matrix multiplication. This is for the matrix which only satisfies the demand that A must be the M by R matrix, B must be the R by N matrix. Hence, we can multiply the two of the matrix. The product must be the M by N matrix. So, let's look at the example. And we have the two matrices that satisfy the requirement. We only put 1 times 4 plus 2 times 5 plus 3 times 6, then we can get the answer 32. The third part, we're looking about the identity matrix. This is a standard form of identity matrix. We can look the rule of identity matrix, which they both contain 1 and 0. And we can see that all the diagonal numbers are 1. These are the example of I2, I3, and I4. First part, inverse matrix. Let's look at the definition of inverse of a square matrix. Let A be an m by n matrix. If there is a matrix B such that AB equals BA equals IN, then the B is the inverse of A. After that, we can look some example of the square matrix. 2 by 2 matrix you need. If you want to find the inverse of a 2 by 2 matrix, you need to find the determinant of the 2 by 2 matrix first. But if the determinant of the 2 by 2 matrix equals to 0, this matrix didn't have the inverse matrix, so we need to satisfy this demand, and then we can calculate the inverse of the matrix by using this formula. The fifth part about the definition of determinant of a square matrix. We cannot calculate the inverse of a square matrix with n bigger than 2 because it's a very sophisticated process. So we can only calculate the determinant of a square matrix. I will show you a very simple tips which is very useful. Then you can use this formula to calculate the determinant of this matrix. This is the tip. And the sixth part about the definition of echelon form of matrix. This is the form which you need to remember. Let's look at the simple questions which use the matrix to solve the three-dimensional system of first-order equations. We need to satisfy row echelon form of matrix. First, you need to find the coefficient of x, y, z and the answer. And then our final goal is to reach this. So we need to use the multiplication and addition or subtraction to find the final goal. We have a different way to reach the goal. This is one of our methods. The last part is the part you can understand these questions, then you will be okay in this knowledge. First, we need to put the denominator factors into x plus 3 times x minus 5. And then clear fractions by multiply both sides of the above equation by this to obtain this. The first step. Comparing coefficients on the left and right side of the above equation, we obtain the following system of two equations in the two variables in A1 and A2. At last, we got the A1 equals 2 and A2 equals 3. So this is the answer. And bye.